Alright, move on. A cable pulls a wooden crate at 30 degrees angle across a rough warehouse floor at constant velocity. The initial free body diagram shows four forces: tension, friction, normal force, and weight, which is Fg. If the kinetic friction coefficient increases while speed stays constant, which revised free body diagram is correct? The most important thing in this question is the wooden crate is moving at a constant velocity, which means it is at equilibrium. I think I spelled it wrong, but I think it's correct. What does equilibrium mean? Which means the net force of all directions must be zero. Alright, let's look at those free body diagrams. First, for this one, the vertical components is this force and this force. It is already balanced, right? However, this tension force will affect the balance because when you figure out the the vertical components of this tension force, it will actually be this one is 3 plus the upward force also 3. It's not equal to the downward force, which is 3, because this is pointing upward. This is will also give it an upward force, which is also 3. And 6 is not equal to 3, so this one is not correct because it is not at equilibrium. Now let's look at the second one. The second one also also divide this tension force vector into components. Let's just do this. This is 3, right? This is also 3. However, the gravitational force right here is only 5. It's only 5. And 3 plus 3 is not equal to 5, which means it is also not at equilibrium, which means this is also wrong. Let's look at this graph. Vertically, this one has a magnitude of 4. This one has a magnitude of 1, 2, 3, 4, 5. Well, 5. Let's divide this vector into components. Vertically, this has a magnitude of 1, and it is pointing upward. It's starting from the central mass and it's going upward, which means it has positive 1. Vertically, 5 is equal to 4 plus 1, which means vertically it is at equilibrium. And then let's look at horizontally. Horizontally, it has a magnitude of 1, 2, 3. It has a magnitude of 3. And this force, I think it's friction force. Yes, it is a friction force. It's also equal to 3. Horizontally, 3 is equal to 3, which means vertically it is also at equilibrium, which shows that, or which means this is at equilibrium, which means this is the correct answer because, yeah, in the question it says at a constant speed. It just wants you to find out a graph or a free body diagram that shows that the crate is moving at a constant speed or at equilibrium, or every component, the sum of all the components is equal to 0. Let's look at the vertically. Let's first divide these two components. This has a vertical components of 2. This vector has a horizontal component of 3. Horizontally, this force, the friction force, also has a component of 3. 3 is equal to 3, which means horizontally the crate is at equilibrium. However, vertically, the normal force has a magnitude of 4. The gravitational force has a magnitude of 5. However, the tension force has a vertical vector with a magnitude of 2. 4 plus 2, which is vertically, the normal force plus the vertical components of this tension force is equal to 6. It's not equal to 5, which means it is not at equilibrium. So D is not correct. C is the correct answer.